Hello guys, hello everybody in the world. Hello Philippines. I'm come back, going back to business. Oh my gosh. Going back to business. Okay, let's go back to the computation and calculation of problem solving regarding fluid flow. Okay, under transfer phenomena, specifically momentum shocks. Okay, where's that? Because so before that, oh my gosh, I need to off the water flowing here. Gosh. Okay. Take a while. Hello guys. So I will read first the problem, Okay. Water is flowing at a velocity of 3 meters per second. In a constant area pipe, 540 square centimeter. A water jet with a velocity of 27 meters per second enters the pipe at section 1 as shown in the figure. Jet area will be taken as AG is equal to 45 centimeters square. There is another fluid, which is the jet. Assume dimensionless, frictionless flow, and the pressure of the jet and the water flow in the pipe to be the same lang siya, okay, at section 1. Calculate at section 2, far away from the jet, the average velocity and the pressure gain. Okay, this is the problem. If you take down the problem, take it down and solve for yourself also. Okay, like this. Oh my gosh. So it's written in a red, okay, red pencil pen. Okay. And at the back also, this one. Red pencil pen, okay. This is the problem. Okay, this is a fluid flow, right? Under fluid dynamics. So specifically momentum transfer. Okay. A lot of problems also in momentum transfer, and we will be able to choose only, not choose, it depends on the kind of problems that we will be able to solve. If it is really under the topic for this momentum transfer, we have to solve also. Okay? But if it is not, then we will not solve. Because there's a lot of problems also from mass transfer and heat transfer that are mixed along with momentum transfer because these are all transport phenomena, man. Okay? So we will choose only the fluid flow. And not also all fluid flow problems will be chosen. Okay, it depends on the situation. There are still long problems, longer than this. Okay? Okay, but we will stick to more basic. Okay, we should not try to solve a very difficult one, right? Okay, like that. But we don't know yet. Okay, because there's small. There's only few given for this. Okay, that's why I choose this one. Okay, let's solve this on the spot. Okay, I'll choose this because it has only small, a few given. Okay, not too much. Okay, and there's also assume. I want to have like that so that we can simplify our equations. Okay, the word create too much critical thinking with so many given, right? Okay, so here is the drawing. Okay, the drawing is here. Okay. Okay, so the area of the jet is opening space and it will goes there. And after that, so let's say that it's point J and going to point 1, then point 2. The point is the output. Okay, it will go there. Okay, in the output. Okay, it's very clear one shot equal rigid shot of see. Assume one-dimensionless fractionless flow and the pressure of the jet and the water flow in the pipe to be the same. Okay? So, pareho siya. So, nasa yung mga constant. Sige, mag-solve na ta. Wow. But before that, okay. So, Wala. Kaya ako pa siya ko ano. Diba? Wait for a while. Hala, uy, grabe na siya kayo. Fairness. Let's eat skyflakes. This one, okay? Skyflakes po tayo. For life. Sarap. Okay. Ano siya drawing, no? It's here, right? So, let's start with the diary. So there will be an overall material balance here. So we will say that J plus 1 is equals to 2. So like that. Okay. Point J flow rate or mass flow rate, it will go in point J and point 1 plus, not plus, equal to the flow rate and growth rate. Flow rate, it will go outside. Okay? So the first thing, if you are adding this 2, J and 1, it will become the answer of this output. Okay? Like that. So there are 3 points to consider. Okay? So let's put na. Okay? Saan itong mga given? Wow. Okay. So in point 1, we have the velocity of 3 meters per second. 3 meters per second. Velocity na siya sa point 1 is equals to U1. U1 is 3 meters per second. Okay? Ganon. And then, in a constant area pipe of 540. So the area pipe for this is 540. Okay? $540. Area 1, 540 square centimeter. This one. Area 1 is 540 square centimeter. Okay. And then a water jet with a velocity of 27 meters per second. So the velocity of J here, Vj is equals to, or Uj, okay, it's equals to 27 meters per second. Okay. So na siya Uj. Uj, velocity jet, okay, is 27 meters per second. Enters the pipe at a section, as shown in the figure. Jet area may be taken as 45 centimeter ang area J. Okay? Ano yung area J? Ganun. Area J is equals to 45 square centimeter. dimensionless siya and fractionless flow. So the density is constant already. Okay? Like that. Okay, and then water flow in the pipe to the same at section 1. Okay. Ganon. So, ang ipangutana is average velocity. Average velocity, okay? Average velocity. Average velocity. Muna siya yung unang pangutana, number 1. Number 2, the pressure gain, okay? Pressure gain. Okay. Pressure gain of pressure 2 minus pressure 1. So at first, you will think average velocity siya. So you could say that velocity that coming out is equal to the velocity that going in, the velocity of the jet and the velocity of the water divided by 2. Use average man siya, di ba? Ganon siya pag-compute, pag-averaging. Okay. So possibly you will add immediately and divided by 2. But we need to, we need to consider what's going on man inside this system. So we cannot do that immediately. Okay, because there are other quantities to consider man siya. Example, density, okay, the flow rate, ganon, the area. So we could not say directly, even though we have given all the velocity of the jet and the velocity what's going in section 1. So we cannot say 27 plus 3 divided by 2 muna na yung average velocity. It's not. Okay, we need to consider pa sa mga equations. Okay, there's no such like that, Ana. It's sura siya. Okay? Now, volumetric flow rate again. Okay? Volumetric flow rate. So let's do it individually muna. So, volumetric flow rate in point J, okay, is equals to area of the J as the velocity of the J, okay? So convert na to daan, we should convert first the unit of the area into meters para there's no complication anymore, okay? Wait. Ako sa nang i-throw ang wrapper sa Skyplex. Wow. Okay? So ganun siya. So the 45 centimeter is equal to, convert siya ha. So 100 centimeter is equals to 1 meter. Raised to the power 2. Cancel ang centimeter. Square meter siya. Calculator please. Charot. Okay. So, wait. 100 raised to the power 100 raised to the power 2 is equals to, okay, ganon, is equal to 100 raised to the power 2 is equals to 10,000. So, 45 divided by 10,000. So 0.0045 centimeter squared. Okay, that's the area. Convert lang siya into centimeter squared. Okay, like that. Okay. The area of the jet, which is equal to 45 centimeters squared, was converted to square meter. Okay. The same also in the section 1. Okay. like that. We have 540, right? So 540, okay. So 540 divided by 10,000 also. So 0.054 square meters. Convert also in the area 1. Okay, so nahimo na ni siyang 0.054 square meter in section 1. Okay? Now, substitute na siya. Volumetric flow rate of section 1 or section J. Okay? J lang sa amin, kay J lang itong giuna, no? Diba? So, J. So, J, we have the velocity of the J, which is 27 meter per second. And we have our area J, which is 0.00045 square meters. So our volumetric flow rate in J is equals to 0.0045 times 27. So we have 0.1215 cubic meter per second. So this is the flow rate in the jet. Because there's a velocity of the jet is this 27 meter per squared times the area na i-convert na to. Okay, hindi mo siyang 0.0045. So that i-times din mo siya because the volumetric flow rate equation is this. Okay? Velocity times the area. Okay? Now sa section 1 side, compute. Okay. So VFR 1 in section 1 is equals to area 1 and density velocity 1. So in area 1, we have 0.054 siya. Okay. I-substitute mo siya. Okay, area 1. You will never use the pi discord anymore because the given is already area. Okay? Like that. Meter squared times the velocity in the 1 is 3 meter per second. So we have kalayan sa ano na kuan naman jud ang kuan. Okay. 0.054 times 0.054 times 3. 0.162. Okay? 0.162 cubic meter per second. This one. Okay? Okay. Now you will say volumetric flow rate in the jet. Okay. Volumetric flow rate in the jet plus volumetric flow rate in point 1 is equals to volumetric flow rate in going out. Okay. So volumetric flow rate J, which is the jet, plus volumetric flow rate at 1 is equal to the volumetric flow rate out. Na naman tayo volumetric flow rate sa 1 and sa jet. So substitute na lang siya. Okay? So sa jet, 0.1215 cubic meter per second plus section 1, which is 0.162 cubic meter per second. So we have, i-add mo siya diretso. So 0.1215 plus 0.162. So 0.28 through 0.2835 cubic meter ang atong total volumetric flow rate that will go out is 0.2835 square cubic meter per second. Okay, di na siya mong gipangayo man. average velocity and the pressure gain. Okay, like that. So, since average velocity is the velocity of the two man siya, no? Nag-i-add naman na nato siya. We add the two quantities already. So, we need also to get the formula of the volumetric flow rate in going out. Okay, volumetric flow rate in going out is equals to 0.2835, okay, cubic meter per second is equals to the area out, okay, area out and the velocity out. Area out and the velocity out. Okay, now in the problem you see here, the flow and the pressure of the jet and the water flow in the pipe to be the same at section 1. Okay? Like that. Calculate at section 2. Okay? Ganun siya. So, imong i-equate ang section 2 ang section 1. Section 1, yes. Imo siyang i-equate. Okay? So, but let's best have value of equation 1. This one. Equation 1. Okay? Equation 1. Okay. Equation 2. Doon na ka sa Bernoullි. Okay? Equation which is pressure, okay, pressure going in is equals to pressure going out. Okay, tigsa-tigsaonin mo siya. So sa J at saka sa section 1 is equals to the 2. So anaunin mo siya pag 1. So PJ plus, okay, PJ plus density J, velocity J, 2 over 2, okay, is equals to 2 GH, okay, plus, okay, P1, okay, plus density 1, U1 raised to the power 2 over 2. Okay, plus gravity 2, H2 is equals to, okay, P outlet, okay, like that. P outlet, okay, plus density outlet, velocity outlet, raised to the power 2 over 2, plus gravity outlets times HO. Ganun siya. Grabe. Ito, haba ng equations. Okay, the questions are very long. So, it seems that we will be afraid for this, but we should not be afraid. Okay, there's no elevation issue for here, ha? There's no elevation issue. So, the gravity thing is 0. Okay? Cancel. Okay? Ganon. Cancel siya. Okay? Okay. Now you have to get the volumetric flow rate or work is equals to force times distance, but later na lang na siya, ha? Okay? Para makuha niyo ang pressure. Okay? Let's say work is equals to the change of kinetic energy in 1 plus the change in kinetic energy in the jet, okay, minus the kinetic energy in the outlet. Parang ganun siya. So you will use that also as an equation number 3. What equation is that? Number 3? Okay, diba? So, no, equation number 3. So, work is equals to the change in kinetic energy. Okay. So, U squared over 2 in the J. Okay, like that. Plus the change in kinetic energy in the point 1. Okay, minus the change in kinetic energy in the outlet divided by 2. Diba? J, ganun. Ganun siya mangyayari. Ito, gamitin mo din itong work formula because the change of kinetic energy from point J plus point I or point 1 minus the outlet. Okay, so we will use this formula. So we have the volumetric flow rate already. Okay, so it's very easy to solve. Okay, ganon. Okay, now the area. So check here. So assume the frictionless flow and the pressure of the jet and the water flow in the pipe to be same. What is the velocity of the at a constant area pipe? So constant area pipe siya. Okay, if it is a constant area pipe of 3 meters per second, so automatic also our area in the outlet is 540 square centimeter. Because of this, water is flowing. Okay? Water is flowing at a velocity of 3 meters per second in a constant area pipe siya, 540 square centimeter. We have only one pipe here. Okay? So, of course, the area of the section 1 and the outlet will just the same because we are having only one pipe. Okay? So, there's no change. That's why we said the elevation is 0 because there's no changing in the height. Okay, from the outlet. So this is equal also to 540. So ganun siya. So therefore, we conclude, okay, so volumetric flow rate in equation 1, we substitute already directly the 0.054 square meter and we can get automatically the velocity that will go outside. Okay? Like this, based on the condition. Okay, so velocity outlet is equals to 0.2835 cubic meter per second divided by the area outlet, which is 0.054 square meter. Okay, 0.054 square meter. Okay, 0.2835 divided by 0.054. Our velocity is 0.2835 divided by 0.054. Okay. Our velocity outlet is 5.25. 5.25 meter per second. But this is not yet the, the one we are looking for. Okay. Our velocity outlet is 5.25 meter per second. Let's just use this in this equation. Okay. Like that. Okay. Now, since the area in the outlet is just equals to the area in the one, okay, so let's just use the Bernoulli equation in the one, okay, will be equal to the Bernoulli equation in the number outlet, right? Okay, pareho naman siya. We should not consider the J because the J is another area man siya. Okay? Like that. And then if it's going in the section 1 man siya, okay, it's mixture already between the jet and the one. You get already? So the jet will go there in the one. Look at the drawing, see? The jet will go there in the one, and there's also 0.1 here. So it is understood that the flow rate here will be equal to the flow rate of the two immediately. Okay, or the Bernoulli here will be equal to the outlet already. Okay, because this will go here naman siya. Okay, combine. Okay, so let's say that volumetric flow rate 1 is equal to volumetric flow rate outlet. But we don't concern on that because nakuha naman, we get already the volumetric outlet naman siya. Nakuha na natin velocity. So we will go now to the Bernoulli. Okay, our Bernoulli now will be equal to this point 1 point here. Okay, the 1 and the 2. But don't worry, since we don't practice to solve this, let's just try later, Okay, maybe for our analysis is wrong also. So we need to segregate the computation. Let's see and manage to compare. Later lang siya, okay? So, first analysis muna tayo. That this 1 will equal to out. Okay? So, dito mo focus. Okay? Dito mo focus ha. Dito mo focus. Tingnan mo. Dire. Okay? Another reason also why I do this, I split this out. Because if you will include this PJ also, okay, there's a lot of pressures involved siya. Okay, then if that is the case, so many pressures will be involved, then how can we get the pressure gain? And the question here is only, ano man siya, is only the pressure outlet minus the pressure in the section 1. So it's not mentioned in the outlet, right? So if I will choose this formula, there's so many pressures that it will complicate. Okay? So that's why I'm just equating the 1 and 2 immediately. Okay? Like that. Okay? There's a lot of things also. Or you can equate also the J is equals to the 1, and then after 1 is equals to all. Later we will later do that. Okay? But first we will equate these two first. Okay? Ganun lang siya. Let's do it individually, okay? Para ano, sure. Okay. Let's use equation number 2. Okay. Equation number 2, section 1 equal to outlet. Okay, so pressure 1. Okay, then transpose minus pressure outlet. Ganon. Okay, and then we have the outlet density. So this is again water. Okay, water ba siya? Water. 1,000 kilogram. Okay, per cubic meter. UO, na naman tayo UO, which is 5.25. Okay, raised to the power 2. Okay, over 2. Okay, see? Pressure gain na yun siya. Okay, but minus, okay, density 1,000 gyapon siya, kilogram, cubic meter. And then our UI, nakuha naman siya. Our UI is in the equation here, in the drawing. Where's the drawing here? The UI is 3 meter per second. UI is 3 meter per second. Substitute dito. Okay. Like this. Put that here. 3. Put that 3 meter raised to the power 2 over 2. Ganon. So our pressure gain, like that. Okay. Pressure gain. Okay. Is equals to minus siya, no? So 3 times 3 is equals to divided by 2 times 1,000 equals to 5. Okay, 5.25 times 5.25 is equals to divided by 2 times like this. So 5.25 times 5.25 divided by 2 times 1,000. Again, 5.25 times 5.25 divided by 2 times 1,000. 13,781.25 minus 45. So 9,081.25 Pascal. Okay? So, let's assume that this is our answer muna for this. Okay? Pressure gain, P2 and P1. Okay? Like that. And let's assume also that the average velocity we computed is 5.25 meter per second. Yung outlet, average velocity siya in the fact that they are mixing with each other man siya. So, yun na ang average niya, di ba? Okay? Ganun naman talaga, i-add mo ang dalawang velocities. Okay? So, let's prove pa ha. Okay. Like this. So, ang PJ karon, ato pa na siyang i-ano dire. Okay? So, PJ. So, let's solve for the PI first. Or P section 1. And then, 9,281.25 minus PO. Equation 4 na ni siya. In terms of pressure. Equation 4. So to get the outlet pressure siya, so that we can use that in the relationship with the pressure in the jet. Let's equate the jet to the first section. Okay, like that. Okay. So this one. So PJ, ganun. So PJ, okay, wala pa kakabalo. Okay. Ganon. Sa PJ, density G 1,000, and then velocity sa J, kina siya, 27 siya. Okay, 27 siya. Okay? 27 raised to the power 2 divided by 2. Okay. Plus this one. P1 nga 9281.25 minus PO. Okay. So P1. Okay. Plus 1,000. Okay, 1,000. Okay, U1 is 3 meter per second. Okay. Over 2. Okay. Is equals to the PO, PO lang siya. Plus 1,000. 3 outlet. Ang outlet na to is kuan siya. 5.25. Okay? So 5.25 raised to the power 2 divided by 2. So ganun siya. Okay? So, like this. So we have also PJ minus PO. Okay, like this. So, let's calculate na ha. PJ. Ato lang nag-prove. Actually, nakuha na nato ang answer. We already obtained the answer, but we are not satisfied because there's also difference in the pressure in the one and outlet, and also different pressure difference in the J and the section 1, and there's also a difference between the J and the outlet. There's a lot of possibilities. Okay, like this. Okay. So 27 raised to the power 2 is equals to divided by 2 times 1,000. 27,000. Okay. Okay, 92.25 minus PO. Okay, transpose negative PO. And then plus 9 divided by 2 is equals to 4.5. 4.5 times 1,000. So 4.5. So 5.25 times 5.25 divided by 2 times 1,000. 13,781.25. So this is PJ minus 2PO. Okay. And then, i-add mo duha rin, transpose na yun. Okay. So, 27,000 plus 4,500. 7,000 plus 4,500. Okay. Plus 9,218.25. So 40,078.25. Then 13. Okay. 13 781.25. So subtract siya. So 781.25 minus 781.25 is equals to. So PJ to PO is equals to 37,781.25 minus 47,881.25 is equals to negative 27, okay? So this is our equation 5. Okay? Equation 5 here, huh? Okay, equation 5. This one. So in equation 5, this can be simplified as, okay, equation 5, okay, 27 divided by 2. Okay. Let's multiply this by 1/2. Okay. So 1 divided by 2, 1 divided by 2. So 0.5 pg. So 2 cancel to 7 divided by 2. 13,500. It's okay, you will not multiply. Just leave that one. Okay, no problem. Equation number 5, this one. Now, since your equation number 5 is a little bit of complicated for the pressure gain, so you will equate directly the one and the outlet. Let's see. Okay. Equate. So it's already class. The outlet already class, right? This one. 9,281.25 Pascal. Okay. So this is really the answer. Okay. Like that. Okay. The pressure is 9,281.25 Pascal. Because if you try to equate the total, then it will involve another, equation that is not simplified already. Okay, like that. This is the overall, right? So if we let also another analysis, okay, we need to. Ang hirap if this is really in the spot. Okay, we need to equate the 1 and 2 class. We obtain it as Pascal, and then we equate. Let's say the J and the outlet. No, we cannot equate the J and the outlet because there's 1. Okay, so in the analysis it will become wrong. Okay, you understand? We cannot equate directly the jet. Okay, the flow jet to the outlet because the 1 will be added man siya sa jet. Okay, so it would be the total, this one supposedly. This one. Since we obtain like this, okay, PG minus 2PO, it's not yet simplified man good siya. There's still point something. Okay, then how can we solve for this? If we divide this 1/2 and then 0.5 and then, okay, so let's try to simplify it. Para lang siya ma-simplified siya. So 0.5 PJ, okay? So 0.5 PG, PO na lang siya. It's equals to 27 divided by 2 also. Divided by 2, 13,500, diba? 13,500 divided by 2. 27,500 divided by 2. Or times 0.5. Okay. Oh, 13,500. Okay, again, multiply this by 0.5 para ma-simplify gud siya pag-ayo. Okay. So this is PJ. So 1 divided by 0.5. 1 divided by 0.5 is equals to 2. So it will never simplify. Again, it will goes back to original number. Okay, di siya pwede. So this equation number 5 is not logical because it's not simplified. This is correct really. PI minus PO is equals to 9,281.25 Pascal. Okay? like that, because for the reason that the J will go to the section 1. Okay, like that. So we cannot equate also the J directly to the outlet because there's still 1, the combined siya. Okay, so ganun siya. So let's another last analysis. We will equate the J to the 1. Okay, let's try. Okay, let's try this another. That's last equation number 6. Equation number 5 is not possible. Okay. What I'm trying to express here is the possibilities. Okay. Okay. Anyhow, I said, Sotero, you made the things complicated. No, I did not make the things complicated. Actually, I got the answer already, okay? Because I don't solve that in actual, okay? I solved just now on the spot, okay? And the answer really is correct, okay? But I need to get another possibilities also. Maybe it's still the same, and let's justify why. Okay, ganon. So in here, unlike to the previous problem solving I did, that I did not get immediately the correct answer. Yeah, I get immediately the correct answer, which is 9,281.1 Pascal. Okay, and the velocity also is 5.55. Okay, normally I will get the correct answers, but I'll never see how it is being solved. Okay, that's my technique. I always read like this, but I'll never show because it will take time for me also to do that. Okay, I'm working, blah blah blah, so on so I don't need time to do that. It's only the time I will do. Okay, during day offs, then on. Okay, so that's why. Okay, it will take time for me, especially if I cannot have time for that. Okay, like that. So let's equate the chat to the to the 1. Okay? Assume lang yung dato ni siya ha. Pero I think sablay pa na siya, pero I will try our best. So you will think, so why you make it complicated? You already get the correct answer. Let's just have a possibility siya. Okay? Then we can compare because, to the given values. Okay? Like this. Okay, now we have the ganon. So, the PI, or the PJ, okay, PJ, okay, plus 1,027 raised to the power 2 over 2. Then the pressure is, okay, PI. So, wala pa bang ka? So, PI lang siya. So, PI, and then PI 3 meter per second squared, no, di ba? Okay, gano'n. Okay, over 2. Okay, so equate mo siya. Ganon. So again, nagsamo ka siya. So, pressure J, okay, plus density J, 1,000. Speed 27 meter per second squared over 2 is equal to the section 1, which is pressure 1 plus 1,000, 3 meter per second squared over 2. Ganun. So, pressure gain po ni siya. PJ minus PI man siya. Oh, di ba? Pressure gain po ni siya. Let's prove if we get the same answer. Okay, ningon ba siya sa problem? Asan ito problem, oy? Okay. The problem say, assume one dimensional flow and the pressure of the jet water flow in the pipe to be the same man siya. So, equal yun siya ang pressure sa pipe na flow dito. So, the same na yun siya. Okay, so, padayo na to siya. Nakakaloka. Okay? Nakakaloka. Orada. Okay? So, 9 divided by 2 is equals to times 1,000 is equals to 4,500 siya, no? So, isubtract mo siya. 27 times 27 is equals to 27 times 27 is, oh my gosh, 27 squared na lang siya. Okay? Divided by 2 times 1,000. It's equals to, okay, minus 4,500. So 360,000. 360,000 ang iyang pressure na makuha. Okay? 360,000. Okay? Dako kay siya. Okay? Times. Okay? Wait for a while. Let's prove siya. Times 1,000 equals 4,500. Okay. So 27 times 27 is equals to, divided by 2 is equal to 1,000. This is 364,500. Okay, minus 4,500. Negative PI, negative 360,000. So there's no negative pressure, right? This is equation number 6. Meaning negative, this is pressure difference or pressure, but the question says pressure gain. Gain meaning positive, right? Am I correct? So from the jet, the average velocity and the pressure gain is P2 minus P1. Okay, so our difference in the jet and the section 1 is negative 360,000. This is a pressure difference, not gain. Negative man siya. Gain, positive man gila siya dapat. Okay? Like this. Okay. So this is the pressure. Okay? Like this. So this is wrong. Okay? This is wrong. Because there's no pressure negative. Though you will say, that indicates, sir, that the pressure will be decreased. But take note, this is not a decreased pressure because it's too big. Okay? Okay? By analysis. Okay? That's too big. So in here kasi, inlet minus outlet pressure difference and the gain is 9,281, in which really logical. Okay? But here, PJ minus PI in the section is negative 360,000. That's too big. Okay? Aside from negative, that's too big. So this is wrong. Okay? Okay? Wrong. And the second one also is wrong. The PG minus PO directly without considering the first section, because it will never be simplified. Okay? And then this one, PI minus PV will be correct because what goes in the PI section is the jet. Okay? Na-combine siya. The quantities in the jet will go directly to the 1. So what's in the 1 will equal to the outlet. Okay? You got the point? So this is correct. So the pressure gain is 9,281.25 Pascal, and the velocity of the, okay, average velocity is 5.25. Okay? 5.25 meter per second. Okay? Now you will say, you will add this to and divide by 2 divided by 2. If you say correct, the same answer. 57 plus 3 divided by 2. No, that's too big. That's 15. So it's wrong. Okay? So you will never directly divide the jet velocity plus the 0.1 velocity divided by 2 for the reason that you will use still the equations and other quantities. So it will not be correct. So use the Bernoullli theorem, the volumetric flow rate, continuity law equation, and then if you let this 0.525, this is correct because this is the velocity of the 2 of the 0.1 and the jet, because this is the velocity outlet. So meaning to say this is the average that the 1 and the jet are combining with to produce an outlet velocity. Okay? No. So this analysis is correct. The average velocity is 5.25 meter per second, and the pressure gain is 9,281.25. Okay? We are very just lucky, okay? Because other problems I got confused and I cannot get correct the I cannot immediately get the correct answer. Okay, it takes a lot of time. Now see, 54 minutes only. Okay, 54 and 58 minutes. But usually when I solve problems, it will reach to 1 hour plus because I need really to, to do it slowly, systematically, like this. And I will get errors also sometimes and I have to prove it. And then then it will just go to the point that I get correct answer. It will not be obtained directly as correct. I need to prove. Ang hirap, no? If you do it in a spat manner, on the spot manner. I think whatever situations, if you do it in the spot, it's very difficult, right? Okay, not only in the problem solving, because you are not prepared, of course. Okay, common sense and by normal situation. Okay, so this problem has been solved. Okay, the average velocity is 5.25 meter per second and the pressure gain is 9,000. Ako na-memorize. Sa to? 9,000 plus to siya. Difference magod siya. Okay. If you want to get the PO and the P1, pwede gyapon siya. Bubalik ka dito sa kuan. Sa 1 and 2. Okay? Ibalik mo, then you can get the answer. Okay? Like that. But it's not the concern here, huh? Gain naman siya. Pressure gain naman gipangayo. It's not, what is the pressure of 2 and what is the pressure of inlet? So the question doesn't ask that. Okay, if the question asks that, then you have to solve one by one. Okay? Like this. Okay, madugay tag samot. Okay, charot. Like that. So if we try to solve the work, then gano'n siya. Okay? So the change of kinetic energy in 1 is equal to kinetic energy 2 na siya. Okay, gano'n siya. Or you can say also, kinetic energy in the jet plus kinetic energy in the 1, okay, minus the kinetic energy in the outlet, okay, because all of them have the values naman siya, okay, so all of them have the values and you can get the work already, but you should compare also from the values of the other one and then think the values if it is logical, whatever, because that is work magod siya. When you speak about work, it's total man siya. Okay? So total work in the output is equal to the total work in the input. In here, we have two inputs. Okay? The J and the 0.1. So all you have to do is to get also the kinetic energies of both the 0.1 and J. Okay? Add it and then minus to the outlet. Ganon. So that we can get the change of the kinetic energy, then the value of this is the work already. Okay? Then remember also that the work is equals to force times distance, right? Am I correct? Force times distance. And then force times distance, right? And then you know also that force is equals to pressure times area. And then you put the pressure times area times the distance, right? Okay, is equal to the change of kinetic energy. Okay, and then if you multiply the area and the distance, that is cubic meter. So that is volume. So you have now pressure times volume. Okay, and then so it will complicate because there's a volume. Don't be afraid. Okay, because we have also density in the equation there. Okay, in the kinetic energy. We should consider the density there. Okay, in the energy equation, right? So density U squared over 2, ganon. And then U squared over 2, ganon. Okay, and mass man siya. Mass U squared over 2, right? And then nakay V diri ari. Okay, sa kilid. I don't have to show because it will take time. Okay, so if you have the velocity, volume in the left, and you don't have the volume in the other, but take note, mass over volume is equals to density siya. Okay, mass over volume is equals to density siya. Okay, so makancel ang volume. Okay, makancel na siya. Gano'n siya. So that is already the density. Okay, diba? Density, mass over volume. Okay? since we have the mass there in the kinetic energy, so mass over V, and all of the V are in the denominator, right? So we have also V in the left. So the rule is you have to cancel the volume in the left and the volume in the right. So what will remain is the pressure difference na satud siya. So P1 minus P1 plus PJ minus PO times the volume. Okay, ganun siya. And then, there is the answer. And then, PJ plus PI minus PO. Right? And then you have the value of ano siya, PI here also in equation number 4. See? PI is equal to 9.8125 PO. So you will substitute that there in the PI also. Okay, so this one, this equation for value. So it will be like this, PJ minus, okay, nakakaloka na. PJ plus 9.82 PO minus PO. So ang mabilin na siya answer equal to the answer on the right, and then solve it mathematically so you can have the difference of PJ and PO. Okay? And then PJ and PO. Okay, na-combine naman ang 1. Right? We don't neglect the value of the 1 because we include that in the change of the kinetic energy. Okay? In the Bernoulli theorem. So, the pressure gain there is try to equate if it is equal in this value, 9,800.25. Okay, if it is equal, that means that's also correct. Okay, because the equation of work really is to prove man siya if we are really using the correct, pressure gain or pressure difference. I'll stop only because the answer on the problem is this one. Okay, so no need to prove because it is the answer of the problem that I see. Okay, so it will take time if you just prove. Let's prove it, and it will take time. By using the work is equal to the change in kinetic energy, in which the change of kinetic energy in point 1 plus the change of kinetic energy in the jet section, okay, minus the kinetic energy in the outlet. Okay, and it's mv squared over 2. Okay, so mu squared over 2, and then the formula of mass. Okay, the formula of mass, this is equals to mass over volume. Okay, so there's a value of density times volume. Okay, like this, and the volume will be cancelled siya talaga. Okay, because in the denominator man siya. So if in here we don't use the density. Okay, density is equals to mass over volume man siya. Okay, the mass over volume of the 3 terms, the common is in the denominator. It will be cancelled just on the left because it's in the numerator on the left on the volume, on the work. So cancel the V, cancel the V. What will remain is the answer there. Okay, like that. And then Sotero, why there is no more mass? Again, mass in the fluid flow is not really the concern. So treat that as constant. Okay, so what will remain? U squared over 2. In which that is the formula really of kinetic energy in the energy form. We don't account the mass. The purpose only is to try to cancel the V, the volume, because we don't need the volume here. Okay, like that. Okay, and then the energy equation also, there's no mass in the kinetic energy and the potential energy. So it's really coincide with the equation. Okay, so the reasoning we have now matched with the general equation. Okay, because in general equation there's no mass man siya. Okay, and here also we will just cancel the mass. Okay, because the volume will be cancelled automatically like that, and the mass is treated as constant all throughout. Okay, understand? Charot. Okay. So what will happen now? So ganun siya. So pwede sad siya. Wow. So you will go to the mass flow rate. If you really want to find out, then go to the mass flow rate. Okay, mass flow rate in the jet is equal to mass flow rate in the mass flow rate in the inlet plus mass flow rate of the jet is equal to the mass flow rate of the outlet. Substitute the density, H density. But the problem here, the jet has no density. Okay? You know, the density of water has the mayroon naman siya density. So the jet should always be the water density, then there's no problem. Okay? Like that. Okay, if the density of the jet will be just equal to the water because they're mixing with each other, there's no problem. Okay? So we can get the mass because mass flow rate. Okay, but the problem is there's no time also. Okay, so if there's no time, how can we convert the time in the denominator? Okay, because we need to know the mass naman siya. It's not the mass flow rate siya. You get the point? The mass flow rate is kilogram per second. Okay, and then we want man na para upper lang yun ang mass. So it will never be possible because the time is not dependent here in the problem. There's no time given here also. Okay. Ay, Sir Sotero, you make the problem complicated. Okay, so I'm just, I'm just looking for the possibilities. Okay, that's it. Thank you so much for watching this live streaming. I hope you like that. Like the video, and then you can comment, you can subscribe if you want to. Okay, this is again I'm Singer Eternal Voice. Thank you so much for watching. Click the notification bell or some news updates of I'm Singer Eternal Voice, and then you can leave in comments in the comment section, of course. Okay. And if you want to share it, much better, and then it's up to you. Okay. See you later. Bye bye. God bless everybody. Okay. Nako. Talaga. Ang haba ng solution. Okay. Ganun siya. Wow.